Let's be real. When you hear the word algebra, you probably think of dusty chalkboards and confusing textbooks, right? Well, today we're going to see how algebra is actually less of a school subject and more like a detective's tool, perfect for cracking the codes hidden in everyday life. So, let's jump right in.
Seems like a simple enough question, doesn't it? But what if you bought a whole bunch of stationery and you only know the grand total you paid? All of a sudden, that simple question becomes a real puzzle. Let's open up today's case file.
All right, here's the situation. We've got two friends, two different purchases, but no individual prices. Romella's purchase is our first clue, and Sonali's is our second. Our mission, should we choose to accept it, is to figure out the cost of a single pencil and a single eraser.
Okay, so just like in any investigation, the very first step is to organize your evidence. For us, that means we've got to translate this little shopping story from plain English into the language of math.
So in algebra, whenever there's something we don't know, we call it a variable. It's just a placeholder, usually a letter. In our case, our two big unknowns are the cost of a pencil, we'll just call that x, and the cost of an eraser, which we'll call y.
Now, each of our clues can be written as what's called a linear equation. That sounds a little fancy, but just think of it as a mathematical sentence, a statement of fact that describes how our x and y are related. And here's a cool part. If you were to plot this on a graph, it would always form a perfectly straight line.
Okay, let's do the translation. Romella's two pencils, that's our 2x, plus her 3 erasers, that's our 3y, cost her 9 rupees. And boom, there's our first equation. Then we have Sonali's 5 pencils, or 5x, plus her 6 erasers, 6y, which cost 21 rupees. And just like that, we have our second equation. Our clues are now in math form.
And you know, this brings up a really crucial rule in algebra. Because we have two unknowns, x and y, we absolutely need two separate equations to find one single definite answer. If we only had one of these clues, it just wouldn't be enough information.
So, we have our two equations. But what do they actually look like? What are these two lines of evidence really showing us if we could see them?
Think about it this way. Each equation on its own represents a whole line of possibilities. I mean, maybe the pencils are super cheap and the erasers are expensive, or maybe it's the other way around. But there is only one single point, the exact spot where our two lines cross, that is true for both purchases at the same time. That intersection, that's our solution. And it turns out, when you put two lines on a graph, only three things can ever happen. They can intersect at one specific point, which gives us one unique solution, that's our goal here, or they could be parallel, like train tracks, and never ever touch. That means there's no solution. Or they could be the exact same line, right on top of each other, which means there are infinite solutions.
Now, drawing a graph is great for understanding the concept, but it's not always the most practical or precise way to solve things. So how do we find that exact intersection point using just the math? Well, that's where our next tool comes in. It's time to crack this case, and we're going to use a really powerful technique called the elimination method. And the strategy is actually brilliant. We're going to cleverly combine our two clues in a way that makes one of the variables, either x or y, just poof, cancel itself out. Okay, first things first, we need to prep our equations. If you look at Sonali's equation, it has a 6y. Now, if we could make Romella's equation also have a 6y, they'd be really easy to cancel out, and we can totally do that. We just multiply her entire equation by 2. It doesn't change the facts, just how it looks. So 2x plus 3y equals 9 becomes 4x plus 6y equals 18. And now, look at this. We have our two equations perfectly lined up. They both have that 6y term. They are ready for the showdown.
All right, here comes the magic trick. Elimination. We just subtract the new, smaller equation from the larger one. So 5x minus 4x leaves us with just x. And here's the best part. 6y minus 6y is 0. It's gone. The y variable has been eliminated. All we have left is 21 minus 18, which is 3. We've got x all by itself.
And just like that, bam, the first unknown is revealed. We now know that x, the cost of a single pencil, is 3 rupees. We're halfway there.
Now for the easy part. We take this piece of information we just found, that x equals 3, and we plug it back into one of our original clues. Let's just use Romella's, the 2x plus 3y equals 9. So we just swap out the x for a 3. 2 times 3, well, that's 6. So our equation now reads 6 plus 3y equals 9. To get y by itself, we subtract 6 from both sides, which tells us that 3y equals 3, which of course means y has to be 1.
And there it is, the second and final piece of our puzzle just clicks right into place. Y, the cost of one eraser, is 1 rupee.
So we did it. We cracked the code, we found our values, the case is closed, but what's the real takeaway from all this? The case is officially closed. By turning a simple word problem into a system of equations, we've figured out the one and only solution that fits all the facts. A pencil costs 3 rupees, and an eraser costs 1 rupee.
But look, this was never really about pencils and erasers. What's really important is that this method is a blueprint for thinking. It gives you a structured, logical way to take any confusing situation that has multiple unknown factors, break it down piece by piece, and find a clear answer.
And that is the real takeaway. This is a powerful problem-solving tool that's now in your toolkit. You could use it to balance a budget with different expenses or figure out a workout plan with specific calorie goals. The logic is exactly the same. So, I'll leave you with this. What other everyday puzzles could you solve now?